Okay, class, now that you know how to draw your histogram and frequency polygon, you will learn now how to compare and interpret the dispersion. And you will look at the shapes. There are a few shapes that you need to know, and so that you can describe, and also you recognize the shape. Okay, we go to a few histogram here. First, it is called symmetric histogram. The other one is skewed histogram. So symmetric histogram, if you see the distribution here is like this. It's like a bell shape. Sorry. It's like a bell shape. This one, yeah. So it is called bell shape. And symmetric, why? Because here, if you make one axis here, it's have a mirror image, the left and right, the same distribution, the dispersion quite the same. And for the other one, you see the frequency is nearly the same. It's very uniform, so you call it uniform shape. And it is a symmetric histogram because here you can find a mirror image. If you make one axis here, a mirror image. So very simple. The next one is skewed. Skewed histogram. What's the meaning of skewed? So if you look at here, the graph, the frequency will go up, and then at the peak here, the highest, then it go down here, and you call this the tail. The tail is skewed to the what? This is your right. This is your right hand side. So you call it right skewed histogram. So actually you look at the tail. Here you have also a tail that going up, reach the highest peak, and then go down. This tail is on the left side of the graph. So it's called left skewed. Okay. So a few more here. Other distribution shape. You have a U shape, U shape here. U shape. Different from the bell shape, lah. And then this one is J shape. The frequency will go up, will go up to this highest peak and then stop. So J shape. And don't confuse with this one. This one, this is the left skewed, right? Left skewed. And it's not the same with the J shape. Because why? For the left skewed is reach the peak here, it will go down. Go up and then reach the highest peak, it will go down. But this one is just go up and stop here at the highest peak. It doesn't go down, right? Okay, reverse J shape is just the reverse of J shape. From highest peak, it go down. It is not this one, it go up, stop and go down. But this one is not going up. It's just from highest go down. Reverse J shape. And then finally the last one is bimodal. Bimodal is you have the same peak. There's two peak that the same frequency. So you say bimodal. Okay. This is not the bell shape. You see like bell shape, but no. Okay. So we move to one example to make you understand better. Example 5, diagram shows two histogram. You can see here two histogram representing the time taken by 25 swimmers to different events. The backstroke and the freestyle. 100 meters. Okay, so you look at the graph, the two histogram. The first question is state the distribution shape. So what shape do you see in these two events? This one is bell shape. Bell shape. And this one, you can see it's a uniform shape. Yeah, the uniform shape distribution, bell shape distribution, very easy. So for B, which event has a wider dispersion? Wider dispersion, which event? Okay, you look at here. Here, the higher, wider dispersion means you find the dispersion lah, the highest time you compare with the lowest time. So how to compare? It's in classes, right? So you find the midpoint. You find the midpoint of the highest. You minus the midpoint of the lowest, and then you see what is the value here. Yeah. So this one, if you find this midpoint, it is 99.5 plus 104.5 divided by 2, divide by 2 because you want to find the midpoint. You will get this 102. This one is 72. Yeah, and you compare with this one. This one, the midpoint is 87. I have calculated just now. Minus with this is the same with this one, right? The classes is the same. So you minus 72 lah. So you get this 15. 15. This one, you compare, what do you get? 102, you minus 72, you'll get 30. This one, the distribution is 30, yeah? The range is 30, this one is 15. So, backstroke, yeah, backstroke event has a wider dispersion because the range is 30, or the difference, you can say the difference of the time recorded is larger in backstroke, that is 30 seconds, compared to freestyle, only 15 seconds. Okay, so for the last one, C, between backstroke and freestyle, which event did the swimmers perform better? Which? Okay, let's see which event, which swimmers perform better, backstroke or freestyle? Okay, what does the time give you information? The smaller the time, it's better. Yeah, right? The smaller the time, it's better here. So look at the smaller time, yeah? The shortest time. Here you have 6, 7. This one here you have only, this one 1, 3, right? 3. This one only, this one 6. So you calculate this one compared to this one. You have more swimmers that perform better. Yeah, you have more swimmers that perform better in freestyle compared to this backstroke. Yeah, that's the answer. Yeah, more swimmers perform better. With the shorter time, that means they perform better. A few tips for you. How do you determine the distribution shape using hands? The one that's skewed to the right. Use your right hand. Yeah, you do it like this, the shape, and if you see, it's like your graph. Yeah, and it's moving to your right. Yeah, so it's called, if this graph it is moved to the right, it's the right skewed graph. Yeah, okay. So for skewed to the left, you use your left hand, and this one is this is the graph. Yeah, you see this one. The other fingers, the thumb finger will show to the left. Yeah, that's how you remember lah. Okay, good tips. Okay, we look at example 6. The frequency this time is the frequency polygon. Below shows the selling prices. Yeah, this is the selling prices of the houses that were sold in two different areas, area A and area B in the last 6 months. Okay, so let's have a look at the graph. Okay, so the question is state the distribution shape. Yeah, let's look at the shape. Okay, this shape, if you see for area A, the shape is first is go up, highest peak, and then it's go down here. What do you see? What do you see over there? It's what? Yeah, go up and then go down. There is a tail, right? There is a tail here. So this is the area A. The distribution shape is skewed to the, this is right, right hand side is skewed to the right, for area A. Okay, and for B, if you look at B, area B, the graph is like this. There is a tail over there, and then you go up and then go down. So you have a tail on the left side, go up and then go down. What can you say? The distribution shape for area B is skewed to the left. Look at the tail, look at the tail. The left comes from the tail. Okay, so next, compare the dispersion of the house prices in two areas. So dispersion, highest and lowest value, you compare. Yeah, you just find the range. So here, if you look at the graph, you can see the range. Let's say for the area A, you see the highest value is here, lowest is here. Yeah, so you just see this one, the scale 1 2 3 4 5 6 7, and this one is half and half, that means 8. The scale is 8, the range is, let's say, 8 lah, to simplify it. And then for area B, okay, this is the lowest, this is the highest value. So 1 2 3 4 5 6 7, 7, and then this one is half, also 8. You see, so not much difference. The dispersion is approximately the same, even though the distribution shape are different. So the shape really are different, but the dispersion is approximately the same. Okay, so answered already. For C, which area represent urban area? Urban. And then which represent a rural area? So urban, it's like in the city. Rural is like in the village or kampung lah. Okay, you have to look at the prices. Look at the prices here. You can see that for area A, you can say area A, the houses are cheaper, right? It start with the house start with this one, like 64,999, and then go up to here. But for area B, the prices, the lowest price start here, right? This one. How many buyer here? Maybe only one. If you see the scale, maybe only one. Start here, and actually between this price, like 150,000, the selling price, the lowest is 150. This one, it's approximately 65,000 lah. We say it's 65 lah. 50 more cents will come 65. So the prices in area A is most of the prices of the houses in area A is lower than area B. Yeah, the lowest in area B is 150, the lowest here is 65,000. So you can say that which house is more expensive, the one in the city or in the rural area? Let's say in KK and in Keningau. Of course, the houses in KK are more expensive rather than in Keningau. So you can say that area A represent rural area lah, and area B represent urban area. Why? Because most of the selling prices are lower. Yeah, you can see here, are lower than the selling price of area B, where most of the selling prices are higher. Yeah, most of the selling prices are higher. You see, up to this one, higher than here. The highest also only this range. Yeah, so that's all. That's how you compare and describe yeah, your histogram and your frequency polygon. So with that, you can answer this one. Yeah, 7.1b. You have how many questions? Only two questions. So you can do it. Yeah, now. Thank you.